Dear students, my name is Dr.NH. Welcome to my channel Knowledge Hub. In this channel, I will be teaching chemistry to begin with for CBSE 11th standard students. In future, I will take classes for 12th standard CBSE, and this will have components for those who wish to appear for NEET and JEE entrance exams. In today's class, we are going to discuss about hydrocarbons. What is hydrocarbons? Hydrocarbons is the study of compounds formed by hydrogen and carbon. Carbon has a tendency to combine with other carbons and other elements and forms innumerable number of compounds. So that is very special about the carbon and its chemistry. So in hydrocarbons, we can discuss two main divisions. We can classify otherwise as two main divisions. One is aliphatic and aromatic hydrocarbons. In aliphatic, we have straight chains and cyclic compounds. So cyclic compounds we call alicyclic compounds. Of course, we are not going to deal with them in this class. So we will be discussing about straight chain and branched chain compounds, alkanes, alkenes, and alkynes. So these are CC single bond compounds with CC single bond. Okay, alkenes, they have CC double bond. Okay, CC double bond. C single bond and C double bond. These compounds will have CC triple bond, at least one triple bond. Now the formula for alkanes is CnH2n plus 2. These compounds, alkenes, they have general formula CnH2n, and alkynes have the general formula CnH2n minus 2. So these are the things. Now here in this class, we will be discussing only about alkanes. We will not discuss about alkenes and alkynes. Now, what is the first member of alkanes? If you put 1, so C1, okay? So 3H4. So 1 here, 2 plus 2, 4. Okay? This is called methane. C2H6. This is called ethane. C3H8. This is called propane. So there is some defined method how to name these compounds. So one carbon, if there is one carbon, we have a word root meth. 2 carbons, we have a word root eth. And if it is 3 carbon, the word root is prop. Since they are alkanes, so it should end with A and E. So methane, ethane, propane. Next, we will discuss about carbon little bit. So carbon. What is the atomic number of carbon? Atomic number of carbon is 6. Okay. So we will see how its electrons are distributed in the orbitals. So it has got 6 electrons. Atomic number 6, that means it has got 6 electrons. Now let us take the ground state of carbon. So you have 1s2, then 2s2, then 3 orbitals, px, that is 2px, 2py, 2pz, 3 orbitals. So in the ground state, the electrons, 6 electrons are distributed like this. Okay, now excited state. So in order to form compounds, the carbon will go to excited states, thereby the electrons are distributed in these orbitals. So excited state. So what is happening? This will not do anything because it is really close to the nucleus. One is the 2s2 2p orbitals. So they will distribute, excite and distribute. So 2s2, I am not repeating, and 2x 2p by 2z. So how that will be distributed? One electron from here, 2s will go to 2py, and this electron will go there. So that means this is how all the orbitals are filled, because they are now having an equal energy. 2s and 2p orbitals, 3p orbitals, they have equal energy. So they will hybridize to form sp3 orbitals. Okay, so how that will look like? So the same thing we can elaborate like this. You know, s orbital is like this, huh? Shape of the s orbital is like sphere, and the p orbital, I told you, px, py and pz. So let us see what is the shape of px orbital, what is the shape of py orbital and pz orbital, how they are orient themselves. Now okay, so this is px, this is x orbital, sorry, this is x orbital, okay, this is y orbital, so this is z orbital, y, x, y, z, x, z, y. Now what is the shape of x orbital, px orbital, I mean, it will be like this. This is px orbital. So my drawing is not good, but let us see. So it is like this. Px. Now py. So this is py. Pz. So this is pz orbital. I am not able to draw with the same size of the lobes, you know. So they are like two lobes. This is px, py and pz. Now this px, okay, this px, py, then this pz orbitals, they hybridize to form sp3 orbital. So we are talking about now methane. Okay, we are talking about methane and its structure. So sp3 orbital, sp3. So this is again, they are not uniform because I am not good at the drawing. So this is sp3 orbital, hybridized orbital. Now with this, now each one has got one electron. Now with this, hydrogen will come with this 1s orbital. It will form a compound which is having a like S will come here, another S here, another S here, another S here. So S will give one electron here. So one hydrogen here, one hydrogen here, one hydrogen one here. So they form a sp3 hybridized tetrahedron having tetrahedral structure. So these orbitals are directed towards a tetrahedron, vertices of a tetrahedron. So let us draw. So each orbital, see from the center, one orbital here, one orbital here, one orbital here. So this is sp3 hybridized orbital. These orbitals are directed towards the vertices of a tetrahedron. So this is now C, H, 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 H. This is methane structure. Here this is 109 degree, 109.5 degree. So this is the angle between these two hydrogen atoms. So this is about methane and its structures. I am just giving you the structure of carbon in methane so that you will understand how carbon is able to, in this case, form bonds with the 4 hydrogens. So this same concept can be extended to ethane, propane, etc. Okay. Hydrocarbons, particularly in alkanes, they form sp3 hybridized orbital. In alkenes, they form sp2 hybridized orbital. There will be one pi bond. And then in alkyne, they will form sp hybridized orbital. Then they will have 2 pi bonds. See, for example, in alkyne, 3 bonds. Okay. So out of this is pi bond. This is formed between. This is sigma bond between carbon and hydrogen. Sorry, carbon and carbon, sigma bond. Then this is formed by the overlap of p orbitals of carbon-carbon. So it's a pi bond. So here we have got 2 pi bonds. One sigma bond. This is sigma. This is sigma. This is pi. Again, this is pi. And now we will go deep into alkanes. Okay. We will go deep into alkanes. So in alkanes, we will first see the physical properties. So first physical property, now you see alkanes members 1 to 4, C1 to 4, these members, they exist as gases. Okay, they exist as gases. Number 2, C5 to C17, they exist as liquids. And then C18 onwards, they exist as solids. Okay, now these gases, why they are these are all gases, these are all liquid, these are all solids. The gases, low members, they have very weak van der Waals forces. They are very weak. Between the molecules, they have very weak forces. So that's why you need little heat so that they will separate. So they have no attraction between molecules. So they are gases. So then liquids. These liquids have very close than the gases, and hence they are having a better van der Waals forces of attraction, so they exist in the form of liquids. Solids, because they are having a crystalline structures. So different crystal types and packing, there depends on packing of individual elements, individual member of the compound, how they are packed, what is the crystal structure, so what is the nature of packing, all depends. So that's why they are solids. So now gases I told you. Now these gases, basically we are getting the cooking gas, LPG, that's a mixture of 2-3 gases like ethane, propane, butane, like this, they mix. Then with that they add some ethyl mercaptan for the smell, so that because they don't have water, so you cannot recognize the leakage. So for you to give a sense of smell that there is a leak, they mix ethyl mercaptan. So these liquids I said, of course their boiling point increases from the lower mid, but at one stage they stagnate at 0.8. Water has got 1 gram per cc, but they will not exceed 0.8, whatever it may be. That's why they float above water. This like petrol, diesel, kerosene, they float above water because the density is lesser than water. So that is the reason. And second thing, the straight chain compounds having higher boiling point than the branched chain. Suppose H12. Okay, 3, 3, 3, 9, 9, 11, 12. So okay, this is pentane. So if it is a straight in pentane, its boiling point is higher. If it is branched one, it will be lower. That is because these branched chain compounds take the shape of a sphere. When they take the shape of a sphere, the van der Waals forces, the surface area between two molecules getting reduced. So as a result, like gases, so they need less energy to boil. But in the straight chain compound, the surface area is more, and the van der Waals forces between the compounds is more, so they boil at higher temperature. So we will study about this in isomerism. So we will study this in isomerism of alkanes. Okay. In alkanes, we will see preparation. We will see preparation. So in preparation from alkyl halides, what? From alkyl halides. Alkyl halides. Number 2, reduction. Reduction of what? Reduction of alkenes and alkynes. Okay. Number 3, from carboxylic compounds. Carboxylic compounds. Now we will see preparation from alkyl halides. So what are the methods here? One is Wood's reaction. Number 2, core house reaction. Okay, reaction. Core house reaction. Number 3, Grignard. Reagent. Then we have reduction of okay, of this alkyl halide using a reducing agent. Reduction means supply of hydrogen. Okay, now we will see Wood's reaction. So Wood's reaction. What is Wood's reaction? Now, as I said, we take one alkyl halide and then, for example, CH3, CH2, okay, and take chloroethane. Okay, this is chloroethane. Now, what is the medium here we are going to use? Sodium in dry ether. Why you use dry ether? Dry ether because dry ether controls violent reaction of sodium. So it's essential to use dry ether. So what happens here? We have 2 carbon, right? Now what we will get here? CH3, CH2, CH2, CH3. What happened? We got 4 carbons. So Wood's reaction is used to make compounds with higher carbons. Like you start with 2 carbon, you end with 4 carbons. If you start with 1 carbon, then you end with 2 carbons. So it's very good, beneficial. Now, how we write this mechanism? So take CH3, CH2, Cl, 2Na plus Cl, CH2, CH3. Simple. Eliminate these 2 chlorine and goes with sodium and you get CH3, CH2, CH2, CH3 plus 2NaCl. Now the question is, now this is symmetrical alkane. Okay, this is symmetrical alkane. This is symmetrical alkane. Okay, or a product with even number of carbons. Now the question is, now can we prepare a product with odd numbers, unsymmetrical? Okay, let us try. Let us try. Say for example, let's try like CH2, C. Now, okay. So what is this? Chloroethane, chloropropane. Now we are trying to prepare 5-membered hydrocarbon, that is pentane. Okay, now this will go. What we will get? CH3, CH2, 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 CH3. This is pentane. Okay, N pentane. Now here the problem with this Wood's reaction is, here one compound having 3 carbons another carbon having 2 carbons. So what we expected, we got it. But unfortunately, there will be other products. They also form side by side. What are those? Like CH. Okay, if can I delete this so that I will write the other byproducts, like now one 3 member, one 2 member form N-pentane. Now another chance is CH3, CH2, CH2, Cl plus Cl plus Cl, CH2, CH2, CH3, CH3. So 3 member, 3 member. 2 will try to react, not try to. So this will form what is called hexane, CH3 and hexane, CH3, CH2, CH2, okay, CH2, CH2, CH3. Don't forget either sodium and dry ether. Okay, that you have to mention. Okay, sodium in. Okay, of course sodium is written, so we write dry ether only. Okay, sodium is here, so you write medium dry ether. So here the medium dry ether. It is understood that this sodium is in the dry ether. So you form one compound like this. What is another one that will be formed? Like CH3, CH2, Cl, right? Plus 2Na plus Cl, CH2, CH3. So dry ether. So that will form CH3, CH2, CH2, CH3. This is N-butane. So this is hexane, N-hexane. So when we are trying to prepare an odd number, that is unsymmetrical product, hydrocarbon, that is alkane, N-pentane, we get byproducts like N-hexane and N-butane. So all the 3 we get side by side. The problem is it is difficult to separate this mixture. So that is why this method is not used to prepare an unsymmetrical alkane like N-pentane. So what we can make from Woods reaction is symmetrical alkanes, okay, like ethane, butane, hexane, octane. Dear students, thanks for watching my channel Knowledge Hub. I hope this will be of useful to you. I request you to kindly subscribe to my channel, share with your friends, and pass on your comments and queries, if any, below the YouTube video channel, and I will come up with replies or answers to your queries in my subsequent videos. Thanks once again for watching.